Hey guys, welcome back to my channel. I am Saummya and today we will be moving forward to ninth question of our Love Babbar's 450 DSA sheet series, which is minimize the maximum difference between heights. This is a very important question, people. So let's move forward to our question. This is minimize the maximum difference between heights. Okay, so this is also a very important question, people. So let's have a The question is on Geeks for Geeks platform. So let's first read the question very carefully. This is a very important question, people, so please try to understand this. Okay, so the question is minimize the heights. So we are given an array denoting heights of n towers and a positive integer is given, that is k. Okay, for each tower we can perform exactly one of these operations. We can either increase the height by the value of k or decrease the height of the tower by k. Okay, so what we need to find is minimum possible difference between the height of the shortest and tallest towers after you have modified each tower. Okay, so let's see this by this example. And one thing, it is compulsory to increase or decrease the height by k for each tower. After the operation, the resultant array should not contain any negative integers. Okay, so we can't do that. Okay, let's just decrease one value and leave other values like that only. We need to modify each and every element in the given array. Okay, so let's see, the example is given here. It's 1, 5, 8 and 10. Okay, this is the array and every value denotes height of the tower. Okay, value of k is 2. Output is given 5. For this we can see the explanation. We can see that the first value is incremented by the value of k and the other three values 5, 8 and 10 are decremented by the value of k. Okay, and that's why we are getting the difference as 8 minus 3, that is 5. Okay, so let's see a good explanation for this problem. Okay, so people, let's say this is the given array in which every element represents height of a tower, and this is a sorted one. Okay, so we have sorted the array and an is the largest and a0 is the smallest array, means smallest value of the array. So the required difference that we need to minimize is the difference between an and a0. Okay, so one way to do this, as we need to modify each and every value by k, is adding k to both the values, means adding k to a0 and adding k to an also. But after doing this we will not get any difference in the difference of an and a0, so it will give us no change, which means this is of no benefit. Moving forward, if we increase the value of last element, which means the largest tower, and decrease the height of smallest tower by k, what will happen is our difference will be an plus k, which means the value of largest tower plus k, and the value of lowest tower minus k. This will result in this, which means the difference is getting increased by 2k. So this is not the ideal condition that we need. Okay, so moving forward to our third condition, we are decrementing the value of largest tower and incrementing the value of the smallest tower. So what we are getting is this: the difference is getting minimized by the value 2k. Okay, so this is the required condition that we need to follow. Okay, now we need to see one thing. This thing we did for two elements an and a0. We need to do this for the entire array. Okay, so let's say this is our array and we know that an is the maximum value and a1 is the minimum value. Okay, so what we will be doing is we will be partitioning the array in two halves. Okay, means let's say for the first half we will be incrementing all the values by k, and for the second half we will be minimizing the value, which means decrementing all the values by the value of k. Okay, so we need to do this, but there is one thing that we cannot blindly partition from anywhere. So people, let's try to understand this in a better way using an example. Let's say we are taking this array for example. This is the given array and every element shows the height of a tower. This is the height of the largest one and 21 is the height of the smallest tower. Okay, and the value of k is 10. If we partition our array from here, okay, so what will happen? This value will be decremented by the value of k and the starting three values will be incremented like this. Okay, so what is the difference now? Difference will be 40 minus 31, that is 9. Okay, so this is the minimum difference that we are getting. So we need to do the partition very carefully. Let's see this, what will happen if we do the partition from some wrong value. See, if we do the partition from here, from the middle, what will happen is, now these two values will be decremented by the value of k and the starting two will be incremented. So the array will look like this. Okay, the last two values are decremented and these two. Now the difference is the difference between the last element, which is the largest one, and the smallest. So here people, this 31 is not the smallest value, 13 is the smallest, so the difference will be 37, which is not minimized. So this is the thing we need to keep in mind. Okay, so this was our example. Let's move forward. Let's take this array. Okay, this is the zero indexed array and we know this is the minimum element and this is the maximum element. Okay, so if we partition the array from here, a0 will be the minimum one in the first half and ai will be the smallest in the second half. Okay, so we need to decide which is the minimum element. Like in the example we saw that here 13 was the smallest and not the first element, which means we need to check whether the first element is the minimum or the first element after the partition is minimum. We need to check this. Okay, so now we need to check whether a0 plus k is minimum or ai minus k is the minimum one. Okay, so we will take a variable current minimum in which we will be checking this, which one is minimum, and similarly moving forward we need to check the maximum in both the halves also. Maximum can be either this a of I minus 1th value or this an minus k value. So we will check for current maximum value and the answer that we require will be the difference between this current maximum and current minimum. Okay people, so let's move forward and code for our so people, let's code for this. I will just zoom in for you people. I hope this is clearly visible. Let's move forward. So the very first thing we will be doing is we will be taking an answer variable and giving it the value that is the difference between the last element, which is n minus 1, and the first element. Okay, now we'll taking two more variables, that is current minimum. We will keep giving the shortest value, which is the first element, and the second one is the largest element, which is the last one. One thing more people, the most important thing, all this is applicable if our array is sorted, then only the first element is the smallest and the last one is the largest one. So we'll just sort our array. Okay, now we will be taking a loop starting from the second element, which means the index 1 to last. Okay, one thing to check is the value. Just see this. The resultant array should not contain any negative integers, which means we need to check the value in our array should not be less than k. Then only we can say that the value will not be negative. So just apply the condition. If the element is less than k, then we will just continue. Okay, and now we will need to check for the minimum element. Okay, just current minimum, this will be minimum of this first element plus k and this given element minus k. Okay, and similarly we will be checking for the maximum value, which is maximum of last element minus k, or this I minus 1th value plus k. Okay people, I hope this is clear till now. Now moving forward, what will be our answer? Answer will be, it may be possible that the difference that we get from this current max and current minimum, it may be greater than our previous difference. Okay, so we will be taking the minimum of the previous value of answer, and the difference between the current maximum and current minimum. Okay people, after doing this thing, simply we will be returning the value of answer. Okay, now let's just try to compile and run. Okay, we are getting the expected output. Let's submit. Yes, our code is running perfectly. Okay, so that's all for today people. In the comment section, please tell me what according to you, what is the time complexity and space complexity of this problem. Okay, so people, that's all for today. I hope you're able to understand the solution. Please like, subscribe and share my channel if you're liking this, and please hit the bell icon so that you get the notifications whenever I am posting a new video like this. Thank you so much for watching my video.